Hey guys, this is Mr. Duda again. Consider this a test review for your geometry test coming up on Friday. I'll be sharing your tests with you at noon on Friday at the beginning of your class period, and this should be sent back to me via email by Monday at 2 o'clock. Okay, there's 4 pages that I'll be sharing the pictures with you guys. I think there's 30 total problems, so I wanted to give you enough time to kind of work through it, and then hand it in feeling confident. Okay, so let's talk about things that are going to be on your test on Friday. Okay. So Friday's test talks about relationships in triangles. Okay, so we talked about basically 4 special types of segments. 3 start at each vertex, and 1 starts at each midpoint. Okay, that's crucial to know. All right, especially when you're constructing equations, algebraic equations, to find x or to find a measure of a specific side. Okay, so let's talk about the 3 special segments in triangles that begin at each vertex of the triangle. Okay, so let's talk about angle bisectors. Okay, so angle bisectors would look like this. Let's draw any old plane triangle. Okay, now again, this starts at each vertex. Okay, so if we're going to draw a point at each vertex, and it's going to bisect each of these 3 angles and cut them in half. Okay, so if we assume, and I'm just kind of estimating where this segment will split this angle in half, doesn't matter where it ends up. Okay, but the important thing is that it splits that angle in half. Okay, if we draw a second segment, let's assume it splits that in half. Doesn't matter where it ends up. Just make sure that these 2 smaller angles are congruent or equal in measure. All right, and then the third one would look something like that. All right, doesn't matter where it ends up, but it would split. That's a bad drawing, but it would split that little angle in half. It meets. Okay, those 3 angles, or those 3 segments, would meet at a point of concurrency, all right, or a point of intersection, called the incenter. Okay, called the incenter. All right. Okay, so they start at the vertex. All right. Okay. The second special type of segments that start at a vertex would be an altitude. Okay, let's take the same triangle or something similar. All right, and it'll start at a vertex. All right, so we're going to draw 3 corners, and let's start from the top corner. So we're going to go in a vertical direction, and it's going to go straight down where it forms a 90-degree angle. So at this point, it's this side is perpendicular to that corner. Okay, and if we draw another one, let's see. I'll assume it looks something like this. That looks perpendicular to me, and let's say that guy right there would look perpendicular. So those are your 3 perpendicular bisectors. Now, where these meet, okay, that point of concurrency or the point of intersection, all right, is called the orthocenter. Okay, the orthocenter is where those 3 segments meet. All right, in terms of the 3 altitudes. All right. Okay, and then the third type of segment, all right, that starts at the vertex, all right, would be a median. All right. Okay, draw the same triangle. All right. And again, a median starts at a vertex. All right. And it's connected to the opposite side's midpoint. So if this is the midpoint of this side, that means these two are equal. So that would be considered, all right, one median. All right, one median. Okay, let's start here, and let's assume that this is the midpoint of the side opposite. Let's connect those. Okay, so that would mean these two pieces would be equal or congruent. And then let's assume that this segment, or that point, excuse me, is the midpoint of this segment, which would mean these two set pieces are congruent. I'll draw 3, and let's connect them. And as you can see, they also have a point of concurrency. Okay, and that point of concurrency would be called a centroid. Now, something unique about a median, you guys had example problems on this. If I called this A and B, and this point X, the centroid was point X, what we notice in a median is that AB, the length of AB, it separates up into two pieces, okay? Well, AX would be 1/3. We would say AX equals 1/3 of the entire length of AB. Excuse me. My apologies. 2/3. 2/3. Okay? So AX would be 2/3. So this is 2/3 of the length, which means that XB would be 1/3 of that length of the entire segment. I hope that makes sense. And you had example problems in your packet to kind of refer to. All right? Okay. So the last type of segments in every triangle that meet are called perpendicular bisectors. Okay, let's draw the same triangle. Now, perpendicular bisectors, they're different because they don't start at a vertex. Okay, where they start is at the midpoint. So if we assume that's the midpoint of this side, which means these two parts are congruent, the segment starts from the midpoint and it goes to side opposite, but it forms a 90-degree angle with its starting point. Okay, with its starting point. So that would be considered a perpendicular bisector. Let's start from the midpoint of this side, which means that these two are congruent, and maybe it goes something like that, but it forms a 90-degree angle where it starts. Okay, and then let's say that this is the midpoint here. Okay, which means that these two sides are congruent, and this would probably go straight up. All right, and it forms a 90-degree angle where it starts. Now, this point of concurrency, or point of intersection, okay, that's called the orthocenter. This is called the orthocenter. Again, this is all in your packet. I'm just reviewing some terms and concepts for you guys to be aware of, okay? So those are the 4 types of special segments that are part of every triangle, okay? Okay, so what else should you be focusing on for your test? We talked about a couple things. We talked about the triangle inequality theorem, okay, which says that if I gave you 3 lengths, say 4, 5, or say 4, 5, and I don't know, 7. okay? And I say, can these three legs, 4 inches, 5 inches, 7 inches, form a perfect triangle with no overlap in material, okay? So by rule, the sum of two sides of a perfect triangle would be greater than the third side. So let's see if it works in this scenario. So we're trying to figure out if 4 plus 5 is greater than 7. Is 5 plus 7 greater than 4? And is 4 plus 7 greater than 5? So this is a yes. This is also a yes. And this is also a yes. So if this scenario happens, then these three lengths can form a triangle. Okay? They can form a triangle. All right? Some other relationships in triangles. Suppose we had, let's say we had a, this is not a right triangle, okay? But let's say this was 92 degrees, okay? And let's say this was, let's say that was 8 degrees. Okay, again, this is not drawn to scale. All right, so that gives us 160. So this must be 20 degrees. And again, this is not drawn to scale. Okay. Let's call this triangle ABC. Okay. Now, if I ask you to list the sides in order, or the sides in order from least to greatest. Okay. So the sides from least to greatest, and we don't have any measures, but we do have the angle measures. So if this is the smallest angle, then that means the side opposite must be the smallest side. Okay, by rule. Now, this triangle again is not drawn to scale, but by rule, so the smallest, the least, would be CB. This is the middle angle measure, so the side opposite of that would be the middle length of the triangle. And since this is the biggest angle, the side opposite of that should be, in theory, the biggest side. Okay, so we're looking at angles and their sides opposite. Now, we could also reverse this scenario. So if I gave you lengths of sides, all right, we could also make this determination with angles as well, and we could make some assumptions, okay, with the angle measures if I gave you measures of sides, right? So if this was not given and this was not given, and I said that was maybe 15 inches, okay, and let's say this was, I don't know, let's say this was 7, and let's say that was 10. And I said, list the angles in order from least to greatest. Well, this is the smallest side, so the angle opposite would be angle A. The middle one would be angle B, and then angle C, because it's opposite the biggest side, that has to be the biggest angle. Okay? And you had some homework in your packet on that. All right? Okay. All right, so let's see what else we have to offer for test purposes. I think this would be a really good problem to focus on. Let's see, what did I want to do? Oh. Okay, suppose I gave you something like this. Okay, so we kind of have that picture, all right? And let's say now this is not a median. Let's say the measure of this is I don't know, 40 and 41, okay? 40 and 41. Let's say these two sides were congruent, right? And let's say this was, I don't know, 30. Let's say this was 30 degrees, okay? And this angle right here, which I can't write it in here, I'll draw a little arrow. Let's say that was like, I don't know, 2x minus, I don't know, let's say 10. Let's say 10, okay? 2x minus 10, all right? And so my question would be, write an inequality that describes the possible values of x based upon this relationship, okay? So if these two sides are equal, okay, what happens is if I look at this angle, which I know is 30 degrees, and I look at the side opposite, that has a measure of 40. So let's say 40 inches, okay, 40 millimeters. And then this angle, which we have an expression, is opposite this a small side that measures 41. So in theory, this angle here should be bigger than this angle. Not by much, but it should be bigger. Okay, so let's come up with an inequality. So we can say that 2x, so if this side is bigger than that side, then we can say that this angle, 2x minus 10, should be greater than 30 degrees. Okay, we're just basically going off this comparison. Okay, so now let's find all the possible values that x can be that satisfies that scenario. So if I add 10, I get 2x is greater than 40. So x can be any number greater than 20. Okay? Keep that in mind. You're going to see that on your test for sure. Okay? So you're looking at this relationship to come up with this scenario. So if this side is a little bit bigger than that side, then that would make sense that this angle opposite the bigger side, okay, is a little bit greater than the angle opposite the smaller side. Okay, so you can refer back to that problem. Okay. And then last, I want to go over this one problem, finding the centroid, which I think is important. So let's give you an example, finding the centroid. Okay, and now keep in mind the centroid, this is a point, right? Okay, it's a point of concurrency, it's a point of intersection between three medians, right? Between three medians. All right, now so let's talk about, let's go through an example. Suppose on a graph, okay, you were given 3 points that form the triangle. Okay, so let's come up with 3 points. 1, 2, 3, 4. Let's say 1 point, okay, was 4, 0. All right, and let's say a second point was -2, 0. Okay. And let's come up with a third point. Let's call it 1, 2, 3, 4, 5, 6. So 0, 6. And then let's connect these. So here, here, and there. Okay? Now what we're trying to find is the actual point, right? And of where, right, where the three medians of this triangle meet. So first of all, we have to find the three medians of each one of these sides. Well, how do we do that? So we have these points, so we have to use the midpoint formula first 3 times. Okay, now let's see if we can get away with it here. So the distance from here to here would be 1, 2, 3, 4, 5, 6. So the halfway point would be 1, 2, 3. So we don't need the midpoint formula to find the midpoint of that segment, right? So that would be, so the midpoint here, I'll make it an M, would be 1, 0, all right? So now we can find the midpoint of this side. So let's use the formula with these 2 points. So we're going to say the x coordinates added together would be 0 plus 4 divided by 2. And then the y coordinates, 6 plus 0 divided by 2. So that gives us 2, 3 would be the midpoint of this segment. So let's see where that is. So go over 2 and up 1, 2, 3. So it's right about, and again, this is not drawn to scale by any stretch. If you had a ruler or graph paper, that would be much better. Okay. Let's come back. All right. So let's see if we can get closer to 2, 3. So if we go over, here's 1, 2, and up 3, right about there. So the midpoint here would be 2, 3. Okay. Now you could find the third midpoint, and I'll do it, but you really don't need to, because really all you need to do. So once you connect this vertex to that midpoint, right, and this vertex to that midpoint, doesn't that automatically give you the point of concurrency? You don't need to find this other midpoint, all right, to find it. Okay, so all we need to do is find the equations of these 2 lines and to find that point of intersection. Okay, I hope that makes sense. All right, now, so we found these 2 medians. We don't need the third median. All right. So what we're going to do is I'm going to erase this formula. Okay. And what we have to now find is the point of intersection between these 2 lines right here. Once we find the point of intersection, that'll give us the coordinates of the centroid. Okay. So we need some equations to do that. Okay. So we're going to have to find now the slopes first, because we need to find the equations of both of these lines. Let's first find the equation of this line here, from here to there. So we're going to use these 2 points here to find the slope. So in order to find the slope of that, all right, we're going to take the y coordinates, subtract them, and then divide them by the difference of the x coordinates. And make sure you subtract them in the same order, -2 minus 2. So the slope would be -3 over -4, which would be 3/4. Okay? And again, we're talking about the slope of this segment here, and that makes sense because it's rising. Okay, so now we have to find the equation. So the equation starts with y equals mx plus b. We already have the slope of that line, so it would be 3/4 x plus b. And now we have to use one of these 2 points, okay, to plug in for x and y to come up with the complete equation. So I'm going to use this point here because it has a 0 in it. So I'm going to substitute 0 for y, and I'm going to plug in -2 for x. So I'm going to multiply it by 3/4, and I'm going to add b to it. Okay. So this will give me -6/4, which is -3/2. So I get 0 equals -3/2 plus b. If I add 3/2 to this side, I get 3/2 equals b. Okay. So the equation of this little segment here would be y equals 3/4 x plus 3/2. Okay. Plus 3/2. Now I have to find the equation of this line here. So let's go back and do that all over again. Okay. So I'm going to I got to find the slope first. So I'm going to use 0, 6, and this 1, 0. I'm going to use these 2 points here to find the slope of that really steep negative line. So I'm going to use the y coordinates first. So 6. So the slope would be 6 minus 0, the y coordinates, divided by 0 minus 1, and we get 6 over negative 1, which is negative 6. I like that because that's a nice whole number, right? Okay, so now we're going to plug that back in to y equals mx plus b, but we already have the m. So now we're going to use one of these 2 points. I'm going to use 1, 0. So I'm going to substitute 0 in for y. And I get negative 6 times 1 plus b. So this gives me negative 6. If I add 6 to both sides, I get b equals 6. So this steep line, its equation is y equals negative 6x plus 6. Okay. So now that we have the 2 equations, okay, all we're going to do is we're going to set up, if these 2 y's are equal, I'm going to set this expression equal to this expression, and that'll solve for x. Okay, that'll solve for x. So let me erase all of this. Okay. All right, and now we have, so we erase, I don't need this y, and I don't need this y. So basically I'm going to take these 2 expressions and I'm going to set them equal to each other. So let's put it right here. So we have 3/4 x plus 3/2 equals negative 6x plus 6. And let's solve from there. Okay, now the way I would solve this is these 2 are fractions. I want these 2 to be fractions as well. Okay, so personally what I would do is I would make my common, that since 2 is in the 4, I want this to be equal to something over 4 and that to be equal to something over 4, right? So there was a 1 here, right? So this is 6 over 1, so I'm going to multiply that by 4. This was 6 over 1, I'm going to multiply that by 4, right? So what I multiply on the bottom, I'm going to multiply to the top, and I'm going to change those whole numbers to fractions, right? So now this one has to change as well, because this had a denominator of 2, so I need to multiply this by 2 and that by 2 to get my denominators all to be 4, okay? All right, so this is what we have. So we have 3/4 x plus 6/4 equals negative 24x over 4 plus 24 over 4. Okay? All right. So now my denominators are 4, so I don't need any of these. So I can erase all the divide by 4 pieces of the equation. Okay? Let's clean this up a little bit. Put a 6 there. Let's bring our 3 here. And we're good there. So that's what we have. Okay? All right, so now let's solve. So I'm going to add 24 to both sides, so I get 27x. All right, and in the same breath, I'm going to subtract this 6, and I get, 18? 18 on that side. All right, if I divide both sides by 27, I get a nice, messy, fraction. So let's simplify. So if we divide this by 9, we get 2. Divide that by 9, we get 3. So we get 2/3 as our x-coordinate of our centroid. Okay. Now to find our y-coordinate, because now we have to solve for y, we're going to take our x-coordinate and we're going to substitute into either one of these 2 expressions for x. All right, now I'm going to use this expression, okay? So I'm going to use, let me erase this piece of it. All right, so I'm going to use the negative 6x. I'm going to use the y equals negative 6x plus 6 equation. And now that we know that x equals 2/3, I'm going to substitute 2/3 into negative 6. So I get y equals negative 6 times 2/3 plus 6. That's negative 12 divided by 3, which is negative 4. So negative 4 plus 6. So y would equal 2. Now, if you go back to your video and rewound it, you would see that point of concurrency where those two meetings, we didn't need to find the third meeting, would meet at 2/3 and 2 on that graph. Okay, so this is a long problem. There's a lot of different parts to this problem. Okay, but make sure you go back and review this, because you had a worksheet on finding central, and some of those problems were easy, where you just had to count to find the midpoints, but others you had to go through work like this particular problem, and you may need to do that for Friday's test. Okay, so other than that, make sure you go back and review your packet. Okay, review your example problems. Keep in mind that in those triangles that have medians, keep in mind that 2/3, 1/3 relationship, where the point of concurrency occurs, and make sure your equations have that 2/3 fraction in it. Okay. Other than that, I think you guys should be able to do a really good job on this. Again, please reach out if you have any questions on this video. Please reach out. If there's questions on the test itself as you're going through it, either on Friday or over the weekend, and you have questions, please reach out. I can't give you a specific answer to a specific problem, but I may be able to kind of navigate you toward the right direction per se. Okay. Other than that, good luck, and you'll be getting your test tomorrow at noon. Have a great weekend, guys.